we're going to keep going with linear equations here today, and we're going to be using them to look at scatter plots. We want you to be able to construct and analyze a scatter plot and also be able to find the line of best fit for the data in a scatter plot, also known as a regression line. So in this part here, in section, I should say 2.3, we are going to pull together some of the stuff. So the main idea of algebra kind of on the whole is to look at things in this section. So we want to be able to find patterns and relationships in data, generalize these patterns, and use the data to make predictions for the future. That's one of the big goals of algebra. So we're going to use that in this section and some of your prior knowledge of slope and linear equations to predict what's going to happen later on. Okay, so on your note sheet on number 1, there is a table here of some data. And the data is in the description. It says all states in the District of Columbia, or Washington, D.C., have enacted laws setting 21 as the minimum drinking age. The table shows the estimated cumulative number of lives that these laws have saved by reducing traffic fatalities. So over here, this table right here indicates that data they were just talking about. What we want to do here is take this data then and use it to make some predictions. First, though, we're going to plot the information. So over on this graph here, we want to plot out the information from the table. So everywhere on here, for the year, looking at the x-axis, that's our year, and our y-axis, that's our lives in thousands. We're going to plot these out. So there's one at 1999, 19.1, and 19.1 you got to kind of estimate. Maybe it'll be right about there. In the year 2000, it's 20. That one we can get pretty accurately. That should be exactly right there. In 2001, there were 21. Again, estimate, maybe right about there. In 2002, there was 21.9. Again, you're estimating. 2003, there's 22.8. We want to know in 2015 what that would project to. Okay, so we're going to get there by next drawing a line of best fit. A line of best fit is a line you think best goes through the data points as possible. So I'm going to construct a line here, and you can just do this with your pencil drawing on there, but you want a line that goes through as best as possible. So I'm going to say maybe some kind of line like that. Now you can see, did my line go through all these points? In fact, I want to move this a little bit here. I think we can get this a little bit more accurate. I want to slide this up a little. Slide this side down. There, I think that goes through a little bit better. Now, did that line go through all the points? No, and it shouldn't. You're not doing a dot to dot here like you did back in elementary school. You're drawing a straight line, maybe use the edge of another piece of paper or something to draw a line as best you can through all those points. All right, part C now. Next thing we're going to do. We're going to look at what kind of correlation this is. Correlation talks about the generalization of that line. There's 3 types of correlation. Positive correlation, that's where your lines in general slant up and to the right. Okay, just like this line has positive slope, we would say that these points have positive correlation. If your line of best fit slants down, then we say it's negative correlation. Negative means they're slanting down here. If you just got points all over the place, then we'd say it would be no correlation. Okay, so that's what we mean by correlation. If we look at the points here, it looks like they are generally trending up. So we would say this one has positive correlation, meaning we should get a positive slope later on here. Okay, next, write a prediction equation. Now, your prediction equation is the equation of the line of best fit. So when we talk about prediction equation, there's a place to write this in your notes. It's a line that closely approximates the data. Okay, this is also known as line of best fit, and also sometimes called your line of regression, or a regression line. Those are all terms that mean the same thing. So you might hear this, you might hear this, you might hear prediction line. They're all kind of talking about the same thing. Okay, so how do we get that prediction line? Okay, or how do we get that prediction equation? Well, what you got to do now is pick two representative data points from your line. Whatever ones you think best go through, and it doesn't necessarily have to be points from this table up here, but just any points in general you think best represent this line. For mine, I think maybe this 2002 one maybe looks good, and this point. Those 2 points maybe are my best two there. So now what you want to do is you got 2 points, okay, on my table. That would be this point and this point, and use those to find slope. Okay, you can always find slope when you have 2 points. So just like you did with slope equation, do y2 minus y1 over x2 minus x1 and see what you get. So if we subtract our y's, that's this data, over, subtract your years, 2002 minus 1999. Okay, that's 3 on bottom. On top, we're going to have 2.8. Divide those, and that's going to be your slope. So if we divide that out, we have 2.8 divided by 3. Looks like we get a roughly 9.33333 as our slope here. Okay, and again, this is an estimation. Let's round it off at 9.3. Since it's not going to be exact anyway, we can approximate. Okay, now that's the slope. Okay, that gives us some useful information, but we wanna keep going here and get a equation. Okay, what's the equation? Well, now we need the slope-intercept, a form of that line. We can get that by going back and using our old friend here, point-slope form. Plug in our slope now for the m, and use one of these 2 points again for our x1 and our y1, and we can find the equation there. Okay, it doesn't matter which one you use, they're both equal. Let's just use the first one here. So we got y minus 19.1, that was from here, equals our slope we got 0.93, x minus, and then we need the x part of that point, 1999. So now go through and simplify this, and now we should have our equation here. Start by distributing. Got 0.93x minus, we got to do a little multiplying. So we're going to do 1999 times 0.93, about roughly 1859. And again, this is approximation. It's not going to be exact. And then last thing we need to do here is add over this other value. So now you want to add this. So if we add that on, plus 19.1 to the answer we just had. Okay, one mistake here I did, and this would be wrong. Notice that top number is negative, and I didn't count it as negative. So I need to go back and change that here. It would be negative this number plus 19.1. So make sure if it's minus that you do get that. So our final prediction equation here then would be y equals, our slope is about 0.93, and our y-intercept comes out to be roughly I'm going to round there, about negative 1840. So that prediction equation now can be used to help us do the last part of this problem and estimate how many lives are going to be saved here in a upcoming year. And the one they wanted us to find was 2015. So the year, remember, that's our X value over here is the year. We want to take 2015, substitute it in for the X value, and we should have an equation that'll predict out what it should be. So now it's just typing that in your calculator and seeing what you get. So if we do 0.93 times the year 2015, subtract, and the estimation is it's going to, at that time, save about roughly 34 lives. Approximately 34. Now, is it just 34 lives? Well, really, we should look here. Remember, this says lives in thousands. So actually, our final answer here, we should put that it saves about 34,000 lives in the year 2015. Okay, that's doing a scatter plot and finding a line of best fit or a predict and getting a prediction equation from your line of best fit. Let's try another one of those. Okay, number 2 here. This table shows the amounts of time of 5 different students studied for their AP Euro exam and the grades each of them received on the test. Make a scatter plot for this data. Okay, so just like we did before, you got an X and a Y. Okay, on our table over here, we need to have an X and a Y on there. Okay, there's our 2 axes. So now we want to plot this out. A difference from this one to the last one, though, they didn't necessarily put numbers on here. So we got to put our own numbers. So you got to make sure you can label all the way from the least amount to the greatest amount. If we look at our X's, the lowest one is 1, the biggest one is 12. We got to make sure we can span from 1 to 12. We can't label by ones here. If we go by ones, we're going to run out of room by the time we get to the end and won't be able to fit 12 on there. So instead, maybe let's go by 2s. Okay, 2, 4, 6, 8, 10, 12. Now we can get all our points on there. If we look at our exam grades, the lowest one is 70. The top one's 95. So we got to span from one to the other. We can do that. A lot of times on graphs, if you skip some numbers from 0, they kind of have like it kind of goes back and forth, and then we can start at maybe 70. Going by 2s here is not going to make it. Maybe let's go by 5s. So 75, 80, 85, 90, 95. Yes, that'll work. 100. All right, so now estimate, graph all those on there. Okay, why don't you kind of pause the video, try that out, and then we'll check them. All right, I got these on here. Again, it's an estimation. Look at the points. Next thing would be to draw your line of best fit. So you want a line going through there, straight line that estimates it as best as possible. Let's try doing that here. Maybe something like that. Okay, there's the line of best fit. Notice it doesn't go through all of them, but it kind of goes through the middle of them. Now we want to come up with a prediction equation from there. So pick points that you think best represent this line. And again, it doesn't have to be it doesn't necessarily have to be ones from this table. You can pick anything you think best goes through there. Okay, just so we're doing the same thing. To me, maybe that one looks like a good one, and that one. So why don't you use the first and last one here? See if you can find the slope, okay, because we need the slope. See if you can find the slope from that, and then see if you can also find the equation of the line. You might want to use our point slope form to help you do that. So pause the video, try out, and see what you get for your prediction equation. All right, let's check what you got. Using that, you should have gotten slope, that's about 2.55. I kind of rounded there. Okay, now use your slope in one of the points. I picked this lower one with our slope of 2.55, put it into the slope intercept equation, solved it here. Last step would be add 70 to both sides. Doing that, again, make sure you got negative here. It's negative 2.55 plus 70. And that should tell us what our y-intercept is. Looks like our y-intercept is about 67.45. And so our equation would be y equals 2.55x plus 67.45. That would be then our prediction equation. Now we can use this prediction equation to estimate the last part. So predict what the score of the person who studied for 10 hours. Hours is our x variable. Plug that in and you can get it. So you got 2.55 times 10 plus 67.45. If you multiply that by 10, that's going to be 25.5 plus 67.45. Adding that up, you're going to get pretty close to, looks like 92 would be, or sorry, 93 I think would be what we get here. Let's double check that with the calculator. So we get 25.5 plus 67.45. Yep, looks like it's pretty close to a score of 93 would be the estimate that they would get. Okay, now another way you can do this, your calculator does have the ability to help you do this too. I'll show you how you can do it on the calculator. If you hit this stat button, okay, that's highlighted in red there, and then go to this first one that says edit, hit enter, you can type in an X and Y amount and use your calculator to help you get this prediction line. So in line, or this first one, we'd want to type in everything in that X coordinate, 5, 9, all the X values, 3, 12, and 1. In the second one, then we want to put all our corresponding Y values. So type in 80. I'm hitting down after each one to get to the next one. 95, hit down, 75, 98, and 70. Okay, make sure they're all entered. Once they're all entered, hit that same stat button. Okay, and then if you go over to on the top menu by hitting over to the calculate menu, we want to pick the one that is linear regression. Number 4 on this one, AX plus B or MX plus B, kind of the same thing. Hit enter on that. Hit enter one more time, and the calculator actually gives you their estimate of what the slope and y-intercept should be. So on theirs, they got slightly different here, and maybe my line best fit wasn't as accurate as it could be, but they said the slope should be about 2.725, which isn't a ton off from what we had, and that the y-intercept then would be about 67.25. Again, pretty close here to what we had. So that would be another estimation. So then the calculator's equation would be 2.725x plus 67.25. Is this one okay to use? Absolutely. It's going to give you a slightly different answer, but again, this is an estimation. It's nothing exact. We're estimating what's going to happen in the future by using what's happened in the past. Okay, the last thing, just some other data stuff that you should know. You should be able to find things like mean and median, mode, range, min and max from a bunch of values. Mean, that's where you take all the numbers, okay, add them up and divide by how many there are, also called average. Okay, so if we were going to find the average or mean of all this, we would want to enter all these in your calculator, add them up, and divide by how many. Now I've done this prior to this. If you add up all the numbers here, you would get 1,478. How many numbers are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers across. Too high, that means there's 20 numbers. So if we divide this by 20, that would give you the mean. And if you divide that out, that comes out to be 73.9. So that would be the mean or average. Median, another word for median, like if you think about when you're driving, the median's in the middle, same thing. This is the middle number in this group. Now, does that mean the middle number is like here because this is the middle? No, you're going to have to list these in order from least to greatest in order to figure out where the middle is. So why don't you pause this, write them out in order quick, because we'll be using that anyway in a second to see where the middle is. All right, here's all the numbers in order. Now where's the middle? We know there's 20 numbers. That means we don't have an exact middle. It would be like after 10. So if we count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, the middle actually falls in between there because now we got another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the other side. If there was an odd amount of numbers, whatever that middle one would be the median. If it's an even number like we have with 20, what you do then to find the median is average the two in the middle. So then we would take these two and average them. So if you take 76 and 77, and since we're averaging two numbers divided by 2, that would be it, and you get 76.5 would be the median in this case. Okay, mode. Mode, another word for mode is most. Whatever number shows up the most times, we would write down as our mode. In this one, the number here that actually shows up the most is this last one. There was 2 94s in our set of data. And so the mode is 94. No other number showed up more than once. If you have multiple numbers that show up the most, then you list all of them that show up the most number of times. Range. Range is your biggest minus your smallest. And so on ours, to find that, you would take the smallest number and the biggest number and subtract them. So we got 94 minus 19, that comes out to be 75. So our range is 75. Okay, last two things, minimum and maximum. We just talked about those. There was the two numbers we had just circled. 19 is the minimum and 94 is the maximum. So those types of things you should be able to find from data and have a knowledge of those. All right, try out your practice sheet.